Okay, recording started. Hey everyone. Okay, Suresh here. Today we are in this session. We are going to discuss about some of the data structures, like tree data structures. So let me give a brief introduction about myself, and then we will dive into the concept. So uh, I'm Suresh. I'm a senior software engineer with around 20 years of experience and working as senior software engineer in a health tech. And I worked in many companies and worked on many technologies. So I help IT job seekers and IT professionals to understand data structure concepts, coding entry, coding algorithms, and through live sessions. And I'm interested in connecting with more people and helping them to succeed in their job interviews. So you can connect me or LinkedIn or through Discord servers. Let me put those details in the comment section. Anyone want to give any message or connect anytime? So I'm just putting in the comments there. So in addition to this, I'm also active mentor of NGO nonprofit organization Yes Mentor, founded by a group of industry subject matter experts in various fields, driven with the objective of bridging the skill gap for the college students by educating, empowering, and aligning to the industry needs via focused connect sessions. So we are offering free mentorship around to 8 to 10 weeks, and you will get close guidance from industry experts. So who are willing to share their wealth of knowledge with you. So please check with smentor.org or ping me anytime. So if you are interested to join as a mentee program or mentor, if you are really interested to start sharing your knowledge with other people, so we are always welcome mentors. We have around 25 plus mentors available for free of cost, and they are dedicated to help the job seekers and whoever want to enter into the IT field and understand a lot of concepts that they need to know, which may not be able to get through normal college degrees. So I'm also giving that website link through the chat message. So please go through that as well. Okay, so that's it. A little bit about myself and the and and what I'm trying to do, and you can check my LinkedIn to know more about me and connect me with any time. So now let's start the actual session, and let me start sharing a screen. So I'm just switching off my camera to make sure a better bandwidth and all those. Okay, sharing the screen is here. Window. Yep. Okay. So you guys can see this, and okay. That's the little bit introduction, and now I'm going to show the next session, next slide here, which is expectation. So what we are doing in these code talks, okay? So there is some expectations that I'm expecting. Basically, what you will get is help on understanding the complex logic. So in the developer roles, if you go to any software IT jobs, most of the jobs right now, 80%, they first do the coding jobs, the coding entry, right? So in the coding entry, you have to write the logic for complex. Sometimes you will get very complex problems. So now I'm trying to help you to how to understand the complex logic. And the other thing, you have to practice more to get grip of the concepts. I will give the basic concepts and how they work and why we need to use particular data structures and how to use it, how to solve problems with those data structures. And then I can show you a couple of problems on the particular data structure. But after that, you need to do more practice. And mostly I am going to explain on the problems I practiced before, and most of them are from CTCI, which is um, very popular book. This is one of the I would say Gita or Bible, whatever it is, for interviewers. Without this, it's very helpful, I would say, for whoever is going on IT and software engineering jobs. So everybody should have this book, in my opinion. So if you don't have it, I would encourage you to buy it. So I'm just putting the title in the chat. So most of my problems are from this session, from this book, and also Lead Code, Geeks for Geeks. And there are a couple of SD skills Saturday classes I went in the past, and those are the things I can explain. And there are a few problems I practiced which are there in my GitHub as well. So those are the things, and I expected you to have full knowledge and practice on the concepts, like basic concepts, like you should already know loops and conditions, what is recursion and stacks and queues. So if you know these basic concepts like hash tables and hash maps or hash sets, and a little bit understanding about time and space complexity, so these are the prerequisites, I would say. So of course I will still explain if you don't know about any of these, like I don't know stacks, I don't know queues, I'm happy to explain, but I'm expecting at least have a basic understanding of these concepts. So I cover problems and from these concepts, like I explain arrays and matrix, okay, and strings, linker list, trees, graphs, and different type of sorting algorithms, and dynamic programming, greedy and backtracking algorithms. These are the little bit more advanced concepts. So recently I finished, like I explained all from arrays all the way to linker list, but for a couple of months I took a break. So now I'm restarting the session. So I want to start with again from the trees. Okay. So of course, again, I can explain these concepts, but today I want to focus on the trees. So I can spend a couple of hours a week. So it takes long time to cover these concepts, but it is really helpful for the people who are in the final year of college and who have a little bit time to go through each and every concept and in a depth and understand. But if you are seeking for a job really quickly, so you have to practice more and not only just these weekly classes. So I'm happy to help once a week. So let's make it the conversational meeting. So not a silent presentation. So unmute anytime and feel free to stop me anytime if you did not understand, or if you want to have a point, if you have a point that you want to make, or if you want to share any additional details that I missed. So please feel free to start as a conversation anytime. Okay, and welcome others also. I'm always welcoming others to share their practice algorithms. So please bring your friends as well. So today we are going to start with trees. So as I said, we have bunch of problems I explained on trees, arrays, strings, and stacks and queues, and linker list. We have a bunch of problems I explained in the past. I can repeat again. So today let's start with the data structure called trees. Okay. So I'm going to use, yeah. So, okay, it says my microphone is noisy. Is it clear, or you guys have any problems in understanding?
No, I can hear you loud on my end.
That's great. How about
Yeah,
you,
you're
Naveen?
loud and clear.
Yeah, it's good.
Is it clear? Nice.
Yes, it is.
Okay, okay. So that's good. So are you guys seeing my OneNote, or until now you saw my OneNote, right? I just want to check. I shared a screen a few minutes ago.
Yes, yes.
Okay, okay. So now I started showing a whiteboard, but somehow it is still showing the OneNote, right? Is it still showing OneNote or whiteboard?
Yes, it's showing one note.
A note, OneNote. Okay. I started whiteboard. I don't know why it's not updating. So let me do one more thing. Okay. Oh, okay. I'm sharing entire screen. So let me do share again. Okay. Oh, window. Sorry, I just shared window. Okay. How about now? It's coming up. Okay. Can you see my inking slate? Right? Inking. Whiteboard.
Yes, yes.
Awesome. That's good. That's good. This is what I will use for explanation purpose. So maybe there is a small lag when I am writing and explaining. So please stop me if you are not able to follow through. Okay. So I just want to understand most of you, Samir and Jay and Talks. We have bunch of data structures before trees. I want to just write it down. So first one we have arrays, and we have what we have. We have linked lists. So anyone have idea on this, right? So any other things you want to share? Like we have matrix arrays, of course, a double dimension matrix, and we have strings is also string. String is also a data structure, right? And stack, and we have what is that, queue, right? And we also have hash table, right? Hash table. So anyone have like, I hope all of you had at least some understanding of these data structures. Any questions, or anyone doesn't have anyone have need any introduction to any of these data structures?
Yes, please.
Oh, okay.
Just for those that do not understand it, so since it's an introductory class.
Sure, I will go. So arrays is okay, right? It's a basic array data structure. I hope you all know about it, right? Samir and Jay talks.
Yes, sir.
Yeah.
Yes, I
um,
have an idea. Alright.
Very good. So, and linked list is also one data structure, and strings is the very basic strings. We will use substring, and we array string is just a array of characters, right? You can think of in the C language. So that's a basic thing. And stacks and queues, these are also like last in first out, right? That is LIFO, last in first out is stack. So whoever you put, like, this is a kind of stack of plates or a stack of books. That's a whatever the item you put on the top, that is the something which will come out. Last in is the one first out, right? And queue is something like first in first out, right? Whoever get into the queue, so that guy will promote here, and that is the one which will come out. So first in, before, right? First out, that is the concept, right? So these are the stacks and queues. And coming to the arrays, you all know this is the uh, contiguous elements in the memory, which has a predefined number of elements, and which allows you to define which data structure. Let's say you want to have array of integers, array of strings, array of employee objects, or array of student objects. You define the data type, and you allocate a memory, and you add those elements, right? So it's a sequential and contiguous in the memory, and it's a fixed length most of the times. Of course, array list is another one where you can add more, you can grow the size of it, but array list is also part of arrays concepts. So, and the last one is hash table. So I hope you all know about hash table. Hash table as key value pairs, right? Where you can have a key, and you can map each key to the value. So there will be some hash function that will derive from key to the value. So that's something. Anyone have um, do you need more explanation about hash table, or are you good with hash table, like how to use hash table and functions of hash table? Yeah, please.
Uh, I would, yeah,
Yeah.
yes, sir. I would like to know a little bit more about hash table.
Okay, definitely. Yeah, because that is very important. But until now you are good with, right, stacks and queues, whatever I just explained, Samir. Yeah.
Yeah, I have a very little idea.
That's good. That's good. No problem. We'll go through them, and yeah. So hash table. Let's start with the definition. So hash table is very helpful in data structures, solving a lot of problems. So I'm about to open a definition here. Okay. So here I'm bringing the definition of hash table. So hash table use the hash function to compute an index, also called hash code, into an array of buckets, okay, of slots from which the desired value can be found. So let's go with an example. Okay. So yeah, as I said, key value, right? See, this is a key one. So if you provide the key, it will give you where the exact value is, right? So here is an example here. So let's say the hash function is 20, like 2 percentile. Basically, it's a percentile means reminder, right? So this is one kind of linear probing. Okay, he's going to a lot of details here. Okay, so let's see a simple hash function. Let me explain the simple hash function. Okay, so you want to, okay, yeah, I think he's saying reminder. Okay, yeah, so simple. um, the people, like, let's say you want to create a table, okay, where you want to assign values. Okay, for every key there is a value. For the people who born on the first week of month, let's say you, for let's say just very basic key value. Okay, the people who born on January, okay, they will fall under, let's say they want, like, we have a student, a hypothetical example, a student, and they want to assign a particular color of dresses. Let's say there is an event coming up and we want to assign randomly, so we want to choose a hash function. Hey, the student who born on in January, they will assign blue color. Okay, blue color t-shirts or whatever. And February, right, they will we are going to give a red color t-shirt. For March, from violet. So it's kind of, we mapped January to a value, it's February to a value, right? Now what you're going to do is, so we will take the date of birth. Okay, 1/1/2010, a student born here. So what we do is, we will take the, this is date and this is month. We will take the month and we'll execute here, and what we will get, we'll get blue color, right? So this is the hash function. Basically, by using the value, we are determining, we are storing the value. So here, let's say the student is student number, the number one student, to the ID of the student is 1. So the 1 belongs to here. Is bucketizing. Basically, let's say another student who born on this particular date. Okay, so 6/7, so 7 means July. What is the value for that July? What will be the color, right? So that mapping. So everybody, based on a particular value, they will be mapped to the particular key and value in the hash table. Okay, this is an example. So I hope you understood the point, right, Samir? Is it clear? Yeah, so basically we will take a
Yeah,
key.
yes,
Yeah, basically we will take
yes, yes, yes.
we'll take a value, and we will run with the hash function, and we will determine an actual value that is going to assign to that particular node. Okay, that's the main purpose here, the key and value, basically. And it will also store as a mapping. So let's say, um, very basic. I'm just trying to understand here. The very basic algorithm in arrays is like finding the duplicate. Okay, you have numbers like this: 2, 5, 7, 8, 5. Okay, so what is the duplicate value here?
5.
5. Very easy. Exactly, because you have only 5 numbers you can see, and you can easily tell. But if you want to put this into the system, and if you're asking an algorithm to find out, you need to write the code to find out. Because, and also, let's say if I'm giving you a million items here on the board, how long it takes? It takes definitely long time for you to process, right? So how you doing here is, your brain is basically looking at 2 is distinct, there is no 2 here, 5 is here. Okay, you saved that information, 5 and 7, which is something new, 8, which is something new, now 5. So it looks like something you already memorized in your brain. For few seconds you memorized, okay, 5 you saw, and whenever you saw 5 again, then you immediately saying, oh, this is a duplicate number which I saw few milliseconds back, right? That is the kind of memorization. Basically, this hash table or hash functions or hash map is help you to, um, basically, get that information very quickly. So what I'm trying to say is, you no need to go to and then compare to every number. You know, 5, okay, is there any 5 here, is there any 7 here? So you're taking one number and comparing with every rest of the numbers. That's a brute force method, right? So but if you memorize that these are the values, let's say you have million numbers here, not just 5 numbers. What you're going to do is you are going to put everything in a hash set. Hash set has only one value. So you the only key will be there. There is no value. So here we are not mapping these numbers to any other values. What we are doing essentially is simply we are putting whatever the value you found. Okay, we found 2, we'll put 2 here. We found 5, we'll put 5. We found 7 and we'll put 8. So for every time if you encountered a new number, you will put it into the hash table or hash set only if it is not there. So that's the main advantage of hash set or hash table is order of one um, checking. So basically retrieval. So you can simply, even though the hash set or hash table has million items, you can simply with one condition you can ask, hey, do we have 7? Do we have 8? So that is the main advantage of hash table or hash set compared to an array. In the array, you have to go all the way from the first element to that particular point. You need to traverse the entire array to figure out whether particular number is there or not. But in hash set or hash key, it's very simple, right? So that is the advantage. So for any a of I, let's say this is a. So you can, let's say this is hash set h. If h dot consist or exist, or there are a lot of contains, there is a method called contains a of I. So that will tell you if hash table contains this value, this could be 2, this could be 5. So it will be replaced I. You guys know the for loop, right? You run the I with 0 to n minus 1 of the number of elements, and you check the hash table. If it is not part of the hash table, you just insert that item. Okay, 2 is not part of hash table, let's insert. 5 is not there, insert. 7 is not there, insert. 8 is not there, insert. Now the next number is 5. Hey, 5 is already there. That means you stop the navigating further numbers, even though the array has another 10 elements or 100 elements or even million elements. You don't care because you found a duplicate, right? The, let's say, algorithm is like find a first duplicate. There could be another duplicates, but the algorithm is saying first find duplicate, then immediately you stop there. Since you found 5, you can simply return 5 as answer. That is the advantage of hash table. You can simply check whether it is there in the um, in the in the hash table or not. You can put the values. It's a memorization concept. You can memorize. Okay, is it clear? Just give a thumbs up or something, say, so that I can go to the next topic. Samir, is it clear? Okay, I did not hear the response. So Jay, is it okay to go to the next concept, or do you need any more explanation on this hash table or hash set? Okay, I think I saw Samir would like to speak. Yeah, please go ahead, Samir. Yeah. Oh, disable. Yeah, please go ahead. Do I need to unmute, or you can unmute yourself, right? Yeah, please go ahead.
I think it's there.
Ask to unmute or ask. Oh, okay. Yeah,
Yeah,
go ahead, Samir. Yeah, please. Yeah,
I, I am clear on this topic. Yeah, this is what I want to ask.
very good, very good. No problem. Anytime, just unmute. You know, need to raise hands. Just a
Yes,
conversation. Yeah,
I
great.
just want to
Yeah,
say I got the concept.
very good, very good.
I
So just
understood it.
very good. So there is one more slight modification. Let's say in this particular same algorithm, I first initially
Yeah,
said, okay, fine.
I just want to say I understood this topic. Yeah, that's it.
Very good, very good. Thank you, Samir. Thank you, Samir. Okay, so let's say the question is in this algorithm. The question says, okay, find first duplicate. Okay, you stop here and find 5 is the first duplicate. Now the let's assume that the question is something like this. Hey, find um, first duplicate. Okay, or find there is one duplicate number. There is only one. There is a 200 or let's say 1,000 items, but only one duplicate number is there. Rest of the numbers are unique, but how many of the duplicate number was repeated, or let's say multiple numbers are duplicated, right? Let's say 5 duplicated 2 times and 8 duplicated 3 times, okay, and 9 duplicated maybe 2 times. So we want to know how which are the duplicate numbers, and what is the frequency of those numbers. Just stay like it's a grades, you can think of as a grades or marks. So we want to know how many people got the rank or rank, how many people got rank 5, how many people got rank 8 or grade 8, whatever. So that's what we want. How can you do that? That is also possible with the hash table. In the hash table, what we are going to do, so we, in addition to the key, we will also maintain the frequency, key and value. Okay, 2 repeated 2 repeated 1 time, 5 repeated 2 times, here is 5 and here is 5, and 8 repeated 3 times, right? Here is 8, here is one more 8 and one more 8, and 9 repeated 2 times. So this is the value. This key is basically the value of the array, and here value is frequency, like frequency or how many times this particular number was duplicated, right? This way, by the end of this whole traversal, you just go through the entire array only one time, right? And you simply put the frequencies. If the 5 is already there, increment. Okay, if the particular number is not there, just add the number with value 1. Let's say here 10. Okay, put the 10. Okay, put the 10 in the table and just put the value 1, right? So whenever you see the 9, you put the value 1, but whenever you see the another 9, you increment the value. Okay, so is it clear? So this is how the hash table will be used. So anytime you can just check it, and then it will also help you to process faster, because you are not back and forth, you are not doing loops, number of loops on the array, right? You simply go only once, and then you just by the end of the traversal, you are ready with the results. Okay, so that's why, now coming to the concept of the complexity. So the time complexity and space complexity, I can explain those quickly before we going to the next topic. So here, can anyone tell what is the time complexity? I just simply call TC. Let's say you have n number of items in the array. Okay, so what is the time complexity? Anyone here talks, Jay or Samir? Any number is fine. You guys know about this order of 1, order of n, order of log n. Any idea on those complexities? Talks. You want to share anything?
Yeah,
Yeah, Samir, go ahead.
yeah. I would like to give a try.
Yeah, please. Yeah,
Uh, yes. Can you please give a try?
yeah. So we have n numbers in the array. So what is the time complexity of this algorithm?
Can I please give a try?
Oh, you want me?
I do not know
Okay.
how to explain it.
Go ahead, talks.
Yeah, like time complexity is nothing but the the time required uh, to the time required to when we run a query. How
Mm-hmm.
how
Yeah.
so it take a long time. So
Yeah,
Uh,
basically, yeah. So time required to evaluate the whole algorithm. You can think of the whole algorithm time complexity is basically, so in the order of we always say order of input. So either the input is n here, like number of elements is n elements, and what is the time? If we have k elements, what will be the time, right? So it's always based on the number of elements in the input. So I think he just dropped off. He may join in a minute, or oh, Jay dropped. Okay, I don't know. Yeah. So Samir, you're right. And Talks, you saying something. Do you want to share what is the time complexity of this algorithm to find out these duplicates? Talks.
uh,
Yeah, go ahead, Samir.
Sorry, your voice is breaking a bit.
Oh, my voice is breaking.
Yeah, a little.
Okay, okay. I think yeah, some network issues are happening, I guess. But what I will do, I will try to close some of the programs here. Yeah, Ashish, is my voice okay? Ashish, Jay actually, Jay joined again.
Yes.
Samir, is it clear now? Is it still okay?
Yes.
Okay, so
Yeah, it's good now.
okay,
Loud and clear.
okay, awesome. Hi, Srini. Srini just joined. So we are just discussing the concept of hash table, Srini, before we go to the trees. So we are just discussing an algorithm called duplicate, finding the duplicates or finding the frequency of numbers. So here we are discussing that we just ran through the algorithm by using hash table. You can keep track of frequency. The key is the value of the number in the table, and value is basically frequency, how many times the particular key was repeated. So now we are discussing about complexity. So here the time complexity of this algorithm is, I'm giving the answer, it's order of, you are going through the n elements in the array at least one time, because you have to navigate the entire array. That means n times you have to do the processing. If you are doing a processing for n times, that means order of n. If you are doing 2 times, it's a 2n. If you are doing 3 times, it's a 3n, right? So that's simple as that. The complexity is like how many times you are processing your logic. Okay. So here I'm taking each number, and I'm checking the hash table. If it is there, I'm just amending the frequency. If it is not there, I'm just inserting the number. That's it. That's just one operation I'm doing for every number. Only one time. I'm not visiting that number again. So that's why it is just only one time from 0th element to the n minus 1. So n elements are there. So time complexity is order of n. Okay. Now what about space complexity? Anyone know about the definition? Basically, space complexity is basically, I will explain immediately. So the space complexity is like order of space or amount of space you required in order to execute this algorithm. Amount of space. So how much extra memory, extra bytes, or megabytes, or whatever you're taking in the memory in order to execute the algorithm. So always remember, the space complexity, when we are determining, it never takes the memory of the input. That means the input is here, order of like n elements are here, you no need to consider that as a memory for your calculation, because that's already given. The n number of n elements already there in memory, and it's not allocated by you. So it's some other program or somebody already giving you those elements for you. Okay. Now in addition to that, how many variables you are taking, how many data structures you are using. Okay. If you are using another array, or if you are using another stacks and queues, in this case we used only one hash table. Okay. So if you are using any additional variables or additional data structures in order to solve the problem, that is where you need to look at how much memory you're consuming, right? So here we are using another hash table here. This hash table, how much memory you are consuming here, how many elements in this hash table. By at this time you can see only 1 2 3 4 5 6 elements, even though we have so many elements on the initial array, but we have used only 6 elements. So to be frank, for this particular array, it's order of 6. The space complexity is order of 6. We just need 6 uh, units of memory. It could be let's say each key value takes 5 bytes. You just need 6 into 5, 30 kilobytes. Just that's the space you need in order to execute these experiments or so. But what about million elements? If you are giving million elements, how many spaces you want in the hash table? Anyone can guess? 50, 100, 200. So hash table, how many elements we will put in hash table? Let's say you have given 1,000 elements. I'm giving you an array of 1,000 elements. Then in the hash table, how many elements you put? It depends, right?
So as it is a yeah.
Yeah. Please go ahead. Yeah. So how many elements if we given 1,000 elements in the array, okay? How many elements you
As
in hash table?
so as it also as table is a key lock mechanism like
Mm-hmm.
mapping. So if you give 100 variables in K,
Mm-hmm.
so we need to take 100 in V also.
Exactly.
So in total that will be 200.
Yeah, let's take key value as one unit. Don't separate key value. Let's say in order to store the key to and its frequency as is a one unit. Let's say you need k bytes of memory, okay, or m bytes of memory, okay. Don't separate that. Let's say in this hash table 1 2 3 4 5 6, only 6 megabytes, 6 MB, just example, or kilo or yeah, megabyte, 6 MB of memory used to insert the 6 elements, right? Now I'm giving you an array of 1,000 elements, okay. Just imagine the elements are 1,000, okay. So then how many units of uh, memory we require for hash table? We cannot say, because you need to depends on the number of elements in the 1,000 array, right? And that depends. Let's say you have all duplicates, okay, then we'll fewer number. Let's say all are non-duplicate. Let's say all 1,000 are unique. The maximum that you need to allocate is 1,000 elements, because you put the number and say frequency 1, you put the another number, frequency 1. So let's say the array was given without any duplicates. We don't know, right? Input can be anything. Input can be 0 duplicates, 1 duplicates, or 10 duplicates, or 20 duplicates. The input varies, but let's assume the worst case. In the worst case, you have 1,000 elements array without any duplicates, okay. Then what are you going to do in the hash table? Because you need to run the entire 1,000 elements to track the frequency, right? So in that situation, the maximum amount, you always need to say these are worst case things. The time complexity and space complexity, you always think about worst case scenario. What is the maximum memory you need, not minimum, okay. So maximum memory you need is order of n, because if you need n, you need 1,000, right? So it is also order of n based on the input. Basically, it's a maximum. Worst case, it will go to n elements. That means every element will be added with 1, frequency 1, frequency 1, frequency 1, right? You got it, Samir?
Yes, sir, I got it.
Nice talks. And Srini, any questions on this time complexity and space complexity?
No.
Awesome. Okay, it's clear, right? So okay, so this is all about hash table. I will jump into our actual topic of this today.
Yeah.
Okay, so our actual topic that we want to discuss today is trees. All about trees. So trees are like this. It's not normal trees that we see outside. So this is the data structure trees. So let's say A, B, C. So what is the main difference compared to this data structure or any other data structure? So in the array, it will be like this, right? A, B, C. And in the hash table, you can put the values, or you can also use stacks and queues to put the, let's say this is queue. So you can put the same values in a different data structures. But what advantage it provides, why we need to do the trees? The trees is basically the hierarchical data structure. It will allow you to define hierarchy. Okay, who is on the top and who is on the bottom? What is the relation between these elements? Those kind of things will is advantage by using the trees, right? So here we are clearly saying A is on the top and B and C are children of A. That representation is not that's what representing the tree. Of course, we can represent the tree in a different ways. Okay, tree is a data structure, but there is a in the code, actually in the code, you can define the tree in a different ways. Some of the arrays in some of the algorithms in some of the blogs and some of the websites, they use array data structure to represent the tree. So representing this, because you cannot draw in the inside the code, right? You have to use some kind of a structure. Could be a class or could be another data structure to represent this tree hierarchy, right? So either you can use a class object with a couple of attributes. I will show you. That is the best way in my opinion. In some of the cases, you can also use an array to represent a tree inside the code I'm talking about. Okay, but what is the advantage of tree, okay, compared to any other data structure? That comes into the dive deep into each data structure. If you dive deep into the arrays, okay, arrays, there are some advantages and there are some disadvantages. Similarly, if you go to the hash table or linked list, I hope you already know. I will repeat again if not. So linked list also has some lot of advantages and drawbacks. And similarly, every data structure has a pros and cons. So by looking at the existing arrays, linked list, hash tables, and other data structures, trees, stacks, and queues, it's a distinct data structure. Trees is always tree has its own properties and the way of processing is different. So now the coming to the arrays has a lot of advantage, right? Where you can access any element. Let's say you want a 50th element, simply a of 49, right? So in most of the languages, the range starts from 0 to n minus 1. So if you want 50th element, you simply say array of 49. That will give you the 50th element. So it's a very direct access. Even if the array has million elements, you can directly say I want 1000th element. I want the element which is at this particular location. You can simply directly access the location. That means accessing an element is always order of 1. So time complexity, it doesn't take any time. You just go there and ask by index, right? That is the main advantage in the array. But the drawback of the array is, let's say you already have elements of 1000, you want to put it in a proper order and you want to insert an element at a particular location. You want to insert an element at 50th location. What will happen if you say a of 49 equal to some element a element employee 1? Employee is an element or object. Okay, what will happen? That will override the value at that location, right? Only if you want to insert, what you need to do, you need to push the elements to the next, like 40th element, 49th element, you need to put it in the 50th index, and 50th element you need to put it right. So basically, in order to insert an element, you have to push the elements to the right, and then so that it will not be overwritten. So it's a very complex operation in order to insert an element at any particular location. That is one drawback of the array. And another one is arrays. When you are defining arrays in any language, you need to define the size. You need to upfront, okay, you want to put employees object. Each one is an employee object. Okay, you need to define, okay, we are creating a company, let's define employee array with employee 1000. Okay, now what will happen is in your data structure, in your software, you can insert only 1000 objects, only 1000 employees. Let's say your company grows big and you have 1001 employee, you want to recruit another 10 employees, you want to add to the same data structure, you cannot do that because it's a predefined. So that is another problem with this. Insertion is problem, and also the size is also predefined at the compile time. When you're creating your algorithm, when you're writing your code, when you're writing your software, you need to define how much memory you need, right? But whereas trees is unconditionally growing, you can simply add childs, you can simply add children here. So you can add children anywhere, it will grow, the tree can grow, as big as it can. Okay, that's the main advantage of the trees compared to arrays. uh, let's compare with the linked list. Okay, I hope you and few folks, I hope you all know about the linked list. How it works is, linked list is linking nodes to one another. Okay, this is one node and this is another node. So every node has two main things in it. First one is data. This one is actually the data of the element. Let's say employee data, you want to put employee, so it's employee data, employee object. And then the next one is the address of the next element. So here is employee 1 and here is employee 2. So here is again the data there, and this is the address of the next element. Okay, if there is no employees, you just simply have a null here. So basically it's a referencing from one object to the next object. Okay, so and in this linked list data structure, always there is always called a pointer called head pointer. So this head pointer always points to the first element in the linked list. Let's say you have 1,000 employees and you have 1,000 linked list. You start with, let's say this is the CEO, and the CEO object will point to the next element. And a manager, let's say example a manager, this manager objects points to the next element. So it's not a hierarchical representation, it's a linking. It's a again, it could not be sequential. There is no need, and in the memory, each object, each node can store in its different location. Okay, that's a linked list. So this linked list has another advantage, is basically it will solve the problem of insertion. So you can, even if you have 1,000 elements, you can add an element in between. Basically you have two elements, so this element points to this one. What you can do is, you can insert a new element here and you can cut this link. I can show you when we are discussing about linked list. So you can cut this link and you can link these two elements, and then you can link these two elements that way. So this is employee 1 and employee 2. Let's say this is employee 2. Now you are employee 3. You included employee 3 in between. So let's say you hired a manager. This is a CEO, and you see until now employee 2 is a manager. Now you want to hire another director or something. You hired this person in between. So now employee 1 is not managing employee 2 directly. So employee 3 is managing employee 2. So that's kind of, it's not hierarchical though, but still I'm just explaining in such a way. So you can just insert element at any point at any point in the linked list. That is the one advantage. But again, the problem is accessing. If you want in a 40th or 50th element, you always need to start from the head, and you need to go through the one each and every element, and then you need to go to that 49th element. That will be your 50th, right? So you need to track the index, and you also need to start from the beginning in order to find that element. So the accessing is the problem. Whereas arrays, accessing an element is faster, but insertion is the problem, right? So that is a linked list. But what about trees? Trees accessing is little bit better than linked list, but not super better like arrays. It's not like order of one. You still, let's say if you want to value C in the trees, right? You always need to start with root and you can go to C. Okay, you want some element here, you go through A, C, and then you can find this D. So you no need to go through the entire element. There are a lot of traversal algorithms I'm going to explain. So that there are finding algorithms, breadth first search, depth first search. Those are the very interesting algorithms that will help you to find element very efficiently, rather than going through every element like in the linked list. Okay, so it is better than linked list, and it's not super better like a hash table or array, because it's not order of one, But why we are using? Because it also has a capability to insert any element at any place. So it solves the problems of arrays, and it also solves the problems of linked list. That is why we use trees, and it represents hierarchical. Okay, I hope it's clear about the introduction of the trees. Okay, I can show you a definition so that it will be easy to follow as well. I hope the page is opening really slow. Okay, here is a tree data structure. Tree has a root, and we call keys and edges. These are called parent and childs. So in this case, if you look at this particular small three elements here, B, D, E. B is the parent, and D and E are the children. Okay, we also call D and E are siblings. Okay, because at the same level. So for this entire tree, A is the root. So this is a subtree. You can call this yellow tree in any particular segment of the tree called subtree. Okay, and there is also called level 0, level 1. Level 0 is always starts with a root. Okay, and then it goes to the next level. So B and C at the same level. So level 2 has 4 elements, right? So, and the last nodes are called leaf nodes because they don't have any children. So those are called leaf nodes. Okay, this is the basic terminology of the tree data structure. So here is I can send you the link here. Very nice explanation of the trees. So trees type of data structure that represent hierarchical relationship with the data elements called nodes. We call each and every element called nodes. So top node is called root. So this is just definition. So a tree is a non-linear data structure, meaning the elements are not stored in a linear sequence like array or linked list, as I said before. So they are not stored in sequential in the memory. So instead, elements are organized in hierarchical structure, with each element have a parent-child relationship. Okay. So this is what the point I try to say. The tree can be represented in many ways, such as arrays or linked list, but the most common representation is a graphical one, which each node is represented as a circle and each edge is represented as a line connecting circles. But in the code, you have to use either arrays or array lists or objects. I will show you objects and with addresses. Okay, coming to the why we need to use, where we need to use. So what is the purpose of using why trees, why we need to use the tree data structure? So unlike arrays and linked list, which are linear data structure, trees is hierarchical and non-linear. So that's why it is representing a company. Let's say you want to represent organizational chart. As I said before, who is a manager, who are the subordinates, or any kind of any structural thing you can represent organization structure. Tree is a very efficient way to represent that kind of data. And searching efficiency. So tree provides an efficient way to search for the data. Okay, and a binary search tree is another type of tree I will explain, that will be more capable of finding elements quicker. Okay, searching for value takes time proportional to the logarithmic number of elements, which is log n. So I will explain, which is much faster than searching in a linear data structure like array or linked list. So they are clearly saying the binary search tree is the way to go if you are really want to have a search capability. You want to store a particular data, million elements or 1,000 elements or 100k elements or anything. So you want to have a searching should be fast. Okay, then it is better to always to go with binary search tree. And sorting. So even sort, if you want to sort the elements by let's say you want to sort the elements or employees by their age or by their salary or whatever different aspects, right? That sorting the elements, sorting the data is always efficient with the trees. So tree can be used for sort data efficiently. Okay, and there are self-balancing binary search trees. Data is automatically sorted. So there is a lot of trees which will, as you are inserting values, it will automatically sort the tree for you. So that way you can get the value very quickly. And we also have a heap is another kind of trees, and this is a little bit different data structure, but that will also help you to find a sorted order of the elements. And dynamic data. So tree dynamic data structure, which means that they can grow and shrink as needed. This means that well suited for applications where the data changes frequently, such as real-time systems. This is another advantage, right? So as I said before, you don't know how many elements you want. You don't know how many employees you want to set up in your softwares, right? So you can use the tree, so you can dynamically grows and shrinks. And as I said, efficient insertion and deletion. So trees provide algorithms for inserting and deleting data, which is important in many applications where data needs to be added or removed frequently. Okay. And easy to implement. Another one is trees are relatively easy to implement compared to like graphs. So that is another way, another reason why we use trees. So I just completed the introduction of the trees and data structure of the trees. I can go next to the different traversals. Okay. Of course, there is another kind of trees called binary search tree. Let's go with the traversal. I can explain binary search tree in the next session. Since we are almost there at the end of the session in another 15-20 minutes. So let's start with a simple algorithm, which is like a different traversal of the tree. Okay, which is in order, pre-order, and post-order. We have different traversals. I'm going to explain them here now. Okay, let's start with a simple tree. So give a thumbs up so far if you understood everything so far, or any questions. I can stop and I can rewind. Are we good so far? Samir talks. Ashwini.
Yes.
Awesome. Thank you. That helps. If you're responding, that helps for. Thank you. So okay. So let's go with the simple, very basic traversal. That means traversal means basically navigating the elements. You can simply call in the array how you navigate. In the array, you can navigate from beginning to the end, or you can start from the end to the all the way to the beginning, right? You can do in different types of traversal. And if you take the stack, there is only one way you always need to pick the elements from the top. If you take the queues, there is always one way. It's like first in first out. There is a in and there is out. So there is a restrictions on traversal for in terms of queues and stack, but array has a little bit flexibility. You can navigate from either from the back or front, or you can also start from in the mid. You can go different direction. But similarly, the tree also has different types of traversal. So there is a three popular traversal: in order and pre-order and post-order. These are the three very um, what we call popular traversal of the tree. So what is in order? In order is simply to remember. This is what I do actually. So left root. Oh no, you can simply call like this: left node and then root. Okay, that's what how I yeah, in order, left node root. Okay, that means you always starts with a left node and then actual node, left child node, and right child. Okay, pre-order means always starts with the node and then check the left child and then check the right child. And post order, you forget about the node, you just process or visit or traversal. These are the different terminology. Process the left child, process the right child, and then process the node basically. So just what I'm trying to say is always have three elements, right? This is a parent, this is a left, and this is right. So in order means you always need to start with the left child. So traversal, why you do what is the purpose of doing traversal is to process something, right? Let's say these are employees of a company. Okay, now you want to display the employee names from this data structure tree. Okay, you can display ABC, you can display BCA, or like you can display it different time, different ways. That's what this is like. What are the different ways to examine the elements of the tree and processing of each element? Okay, now in order, what will happen is you always start with left node. So of course we always have a reference. Let's say r is always referring the root. Okay, you cannot go directly to the b, you cannot go directly to the c. You always need to start with root node. but it is up to you whether you process the root node or not. Based on the algorithm, we will either come to the root, you know, based on the algorithm. So now, as per the in order, what we do is we always starts with the left node. So we'll directly visit A and we will go to the left node of the B, and then we'll print B. Of course, we will check if we have any other nodes or child nodes. Since B is a leaf node, we found the leaf node element, and we simply print B. That's it. Let's say that's the name of the employee. Now what you do is you're done with left node. Now you tackle with the actual node that you started. That means root. That's what A, right? B, A, and then right node, which is right children, and C. So BAC is in order. This is in order traversal. Okay. Now pre-order. Pre-order means, let's say you want to display the values in the tree in the pre-order manner. The pre-order manner means first you always start with the root and you immediately process. N means node, wherever you are. Okay, I'm at the node and let's process that node. Okay, I'm going to process. Okay, I'm printing the employee name, and then I need to go to the left child, which is B, A, B, and then right child, which is C. Okay, that is the pre-order. Now what is the post order? This is a post order. Post order means we will tackle about the node at the end. I don't care about the root. First I want to process the left child, and then process the right child, and then I will consider the root. Okay, that means anyone can tell what is the post order for this? You can put in the chat as well. Very simple. Just want to make it interactive. I'm asking, what is the post order traversal? Srini.
It's a BCA.
Awesome. Thank you. Okay, BCA. Basically, B left child, and then right child C, and then go back to the node and then process it. Okay. I hope it is very easy to understand. Let me go with simple little bit extending the example, and let me ask what is the value. Okay, A, B, C, D, and E. Okay, so can anyone tell the order? I want to start with, since we have three, let's take each one. Okay, who want to tell that in order? Samir, what is the in order?
Yes. First, in this case, so it's D.
Mm-hmm.
I think it's no, it's I guess it is D and D B E.
Okay, sorry, can you repeat? What is the first one?
Yeah, it is in order. It is D
Uh-huh.
B and
Uh-huh.
E.
Okay. Okay. Now we have A, B, C, D, E. We have 5 elements.
Sorry. In that case, it might be D D B
Mm-hmm.
A and C.
Okay.
I think this is the right answer.
So D, B, and then A. You're saying A.
A. So it is right again. It means C and E.
C and E. Okay. Anyone tell whether this is right or wrong? Srini or Talks?
Yeah. It's a little like there is a few corrections are needed.
Yeah. Yeah. Go ahead, Srini. What is the in
Yeah,
order?
it's a DBEAC.
D, B, A, C. That's right. This is correct. So let
DBEAC.
D, B, E, A, C. Yeah, that's what I wrote here, right? Yeah, D, B, E, A, C. This is right. So let me tell you, Samir, what is happening here is what we need to do is in order. Okay. So what is meant by in order? First, you start with a subtree. Just take only 3 nodes, okay?
Yeah.
So, and then process the left child, right? First you take A, B, C, okay? First you need to process the left child. That means you need to process B, and then immediately you change the focus to the B, D, E. You forget about A. Now you are processing B, D, E, small subtree in the in order. That means you need to process the childs of the B or the entire subtree started with B completely before you going
Yeah.
to the A. We should not go to the A unless you complete the entire tree starting with B. So now you forget the top tree and you just look at B, D, E. So what is the in order for this? You need to start with left node D, and then root node B, and then right node E. That is in order, right? Left root, left node root, left node. We are at the node B. Okay, right now the pointer is at the B. So in order to process here, you need to look at the D and then process the D. Processing D, what is meant by processing D? Processing means, do we have any childs, or if you have any childs, you process the in order. That's what it is. So since the D doesn't have any childs, you simply display. Similarly, then go to the node which is B, okay, simply display, and then process the right. Now processing the right node means E. You need to see, do we have any children for E? No, we don't have it. Simply put, simply display it. Now you're done with B. This is the time you're done with the left node of the A. You're done with the left node of the A, right? Now coming back to the same formula, left node is done. Now you need to tackle the node, actual node. Now the pointer back to the A. Now the pointer is still pointing to the A. Now print A, right? Then what is the formula saying? You're done with left node, you're done with the actual node, and then you tackle the right node. Now the right node is C, right? Process the C. Do we have any children for C? No. Just print it. That's why it is DBEAC. Is it clear now, Samir?
Yes, sir.
Awesome. That's
It's clear.
great. Talks, is it also clear for you, right? In order?
Yes.
Awesome. Thank you. So now, Talks, do you want to go with the pre-order? What could be the pre-order for this entire tree? Pre-order says node, tackle the node, and then tackle the left node, and then tackle the right node. Any guess? Talks on the pre-order. So let's tackle the node. Okay, let's take this these 3 nodes. Okay, and what is the node there? So the first pointer is always pointed to the root, right? So what will be the node? Root node. Talks, are you following so far? So you need to process the node, right? Oh, she left. Okay, that's fine. So I will give the answer here. So Samir, do you want to contribute here? So what is the pre-order?
Yes.
Yeah.
So coming to pre-order, first we are targeting the node.
Mm-hmm.
That means A,
Mm-hmm.
A, B, and C.
B.
So next we are targeting the left side. So that is D and E.
Okay.
And E, and then we are going to write that is C.
No. Can you repeat? You said A, B, C, D, E. So I think I wrote it wrong. Can you say again? A, B. Oh, what happened? Samir, Srini also left. So, yeah, go ahead, Samir. So A, B.
Sorry, I can't. Sorry to say, your screen is not sharing. It is totally blur.
Oh, it's not showing.
Now I can see.
Okay.
So for pre, so first we are.
Yeah.
Yeah, it is showing me now.
Yeah.
first we need to target